Hi everyone. So we're here to talk to you today about the computable economy and real-world assets and how this can unlock exponential wealth. Okay. So my name is Justin Bannon, and I'm a founder of a couple of real-world asset protocols, Boson Protocol and also Fermion Protocol.
Yeah, hi everyone, I'm Jason Potts, founder of the Blockchain Innovation Hub at RMIT University in Melbourne and a crypto economist.
So the talk we're going to give today is based on an academic paper that we wrote earlier this year on the computable economy. So to start, if we look at the history of the economy and we go back, say, to the Stone Age, we see this pretty significant growth in human wealth. And if we zoom in a bit on that uptick, what you see is in the last 300 or 400 years, this real strong exponential growth in human wealth. And the question is, what's caused that?
Yeah, so what we want to do is to tell a story of how economies have evolved and what this means for, what crypto is bringing into this story. And we've got a narrative that argues that we are going through a revolution at the moment of a very particular sort. So origin of wealth, the standard story we know about this is new technologies. So, once upon a time this was fire, and then, steel and steam, and we gradually worked our way through a sort of sequence of hundreds and thousands of, new industrial technologies that gave us the modern economy. And that's the story of long-run economic growth, is fundamental new industrial technologies. But there's a second sort of technology that is often overlooked, and this is the one that we want to sort of try and help you to understand here. And this is the technology of institutions. Institutions are a coordination technology. The very first one that fundamentally gave us modern economies 7,000 years ago was writing. Writing enables people who don't know each other to coordinate in space and time by recording facts about who owns what, or whose cow was that, or who owes me some honey. And that sort of beginning of writing 7,000 years ago was the beginning of history and modern economies. First institutional technology was a revolution in terms of human welfare. What other big institutional technologies we've had? Joint stock company, 14th century, 15th century, created the idea of sort of organization of the corporate form to gather resources together. We've had institutions in timekeeping and so on, with universal clocks working their way through. We've had revolutions in democracy and sort of record keeping of ownership and identity and other sorts of fundamental protocols. But the story that we have is that industrial technologies or technological change, fundamentally driven by research and development, is the main explanation for that hockey stick rise. But the reason it keeps going up, the reason we keep getting new and new levels of growth, is that these sort of institutional technologies provide sort of languages and coordination mechanisms to create new generations of coordination technology. And what we are going through now, the sort of the crypto revolution that's being powered up by AI and all of these other digital technologies, is a fundamental new type of economy. We've called it a computable economy. We distinguish this from an industrial economy, where all the fundamental institutions of an industrial economy were done by government, in terms of record keeping, in terms of fundamental asset registries and the money and so on. So this idea of this is where we're up to now in terms of a new institutional technological revolution to create a new type of economy that fundamentally works digitally, fundamentally works globally. We haven't seen a revolution like this for hundreds of years. That's the nature of the sort of technological change we're seeing now. The way we want to frame this is this sort of computable economy revolution, which is an institutional technology revolution made possible by a series of other technologies, you know, computers and so on. What is going on is this is a continuation of the evolution of compute in the universe. We described, you know, the evolution of economies, you know, beginning sort of 7,000 years ago through to the present, as a series of step changes as we moved up the institutional technology stack, from written language through to coordination, so on, all the way through. That process has been going on for millions and billions of years. And the way to think about this is that every so often on the evolutionary trajectory, we get these huge breakthroughs, these fundamental shifts in terms of the underlying sort of language of evolution. Evolutionary biologists call these meta-system transitions. And the idea is that a digital economy is the latest phase of a meta-system transition, where we're able to finally sort of start to write all of the things in an economy to be able to sort of interact with each other. Now, what that means is that where we are now in terms of evolutionary, in terms of the evolution of economies, in terms of institutional evolution, is at a new transition in terms of creating a new computable substrate. And this idea of economies are not like, you know, economies have computers in them, but fundamentally economies are computers. They're ways of computing sort of resources together to create economic value. Markets do that, organizations do that, protocols and platforms do that as well. And that's sort of the next step in terms of how economies are going to develop and evolve, is to really sort of push what we can do with that compute level. Justin.
So if we unpack the nature of this computable economy, let's first look at computers. So, I mean, computers will transmit, store and receive data in a highly reliable way. And computers will also run programs. So if you run the program 1 + 1, it will always equal 2. And because of this sort of reliability and the determinism of computers, you can build highly complex applications on top of them. And if you look at this, you know, our modern sort of internet and digital economy, that's sort of evidence of that. However, if we look at sort of today's economy, what we find is that if we want to sort of transmit value, often what we have to do is transmit via intermediaries, like banks, for example. And these intermediaries introduce sort of risk of default, they introduce fees, they're slow. And also, you know, if you want to sort of store and retrieve value, you have the similar problems. And so, also when you want to run economic programs on the current economy, we do this by having a contract. So let's say, you know, you have a contract with someone to provide a service and they don't provide that service. What do? Well, you have to take them to court. This is slow, it's expensive, and it's fuzzy. So instead of having this sort of deterministic and reliable substrate, we have a sort of a fuzzy, unreliable substrate. And that really limits the complexity of applications that you can build on top. Our claim is that with a computable economy, when we're building an economy on this fundamentally more reliable substrate of blockchains, you get some properties that are much closer to a computer than today's economy. So, you know, smart contracts can enable the transmission of value in a very reliable way. When we want to store and receive value, it's possible to do this in a way that is reliable, but that requires a particular type of procedure for tokenizing these assets, and we'll get into that in a second. But it is possible to do that. And so with this kind of combination of properties, it's possible to run economic programs on a blockchain substrate that give this kind of reliability and determinism that you don't get within today's economy. And the result of that is enabling much greater complexity to be built upon this substrate. So here's our claim, is that blockchain technology enables a new computable economy and unlocks exponential wealth through increased complexity, but the condition is that we've got to tokenize all forms of capital, all assets, with the same strong commitments. And so what we mean by strong commitments are that all the assets that we tokenize and bring on chain need to be trust minimized, secure and verifiable, ownership, and enforced by cryptography. And so, most assets, the current on-chain assets have these properties inherently. And there are many, many assets from things like debt, equity, where they can be transferred entirely on-chain and will then have these kind of properties of strong commitments. But there are always a class of assets that will have a physical residue, physical assets. And these can't entirely be represented on-chain. So there's a couple of problems with physical assets. One is this physical asset oracle problem. So if I tokenize my car and you buy the token, how can you be sure that you'll actually get the car? And then this kind of fair exchange problem of how do we ensure that the exchange that's happened is fair and to the quality and terms agreed. And so you'll find there are a number of generic solutions for tokenizing physical assets. So the first one is this kind of centralized model where you will have a trusted entity that will hold the assets and issue a token. The problem with this is it has exactly the same problems as today's economy, where we're trusting centralized entities, and that doesn't have sufficient reliability for us to kind of have this kind of computable economy. And then there are two other methods. So one is where you lock up funds, and for this method, it's very transaction cost efficient because a protocol can just lock up the funds at very, very low cost, but it's capital inefficient. And so this tends to work for sort of low to medium value items that you would usually use someone like Amazon or eBay for, but it wouldn't work for very high value items. And then secondly, the other method is to lock up the actual physical asset. And here we have, that's more costly because you're going to be using physical entities to do this, but the capital efficiency is much greater because you can release the funds immediately upon lockup. Okay.
Thank you. All right. Why is this a good thing? Why are we sort of excited about this idea of a sort of step change in economic evolution? And the question we sort of want to address here is, what is the argument for why we might expect that hockey stick just to keep going up? Like, what is the argument for why we'd expect to see further and further growth? And the counter argument here is, well, limited resources and finite planet and post-capitalism, and it can't keep growing forever. But the claim here is that it could, and not in the sense of more and more resource intensity type of growth. What we're describing is not economic growth. What we're describing is economic evolution, in the sense that the fundamental coordinating mechanisms of an economy just get better and better in terms of processing distributed information. And this is a sort of crucial insight, is that sort of what is an economy? An economy is a way that a bunch of humans come together and create resources and provision each other. We use it for making stuff and doing stuff. But we also use economies for organizing and growing knowledge. Economies are the basic mechanism by which we organize our resources for innovation and our resources for protection of environment and just all of the things that we want to do collectively. And that notion of economies as coordination mechanisms is the key thing we want to sort of emphasize here. That what just happened with the sort of digital, crypto, distributed, computable economy is that we've got a step change in our ability to coordinate our collective actions together. And that shift, what does that mean? It means that we can start solving much harder problems. So industrial capitalism, what did it do? Many things, but one of the main things that it sort of did was it lifted a sort of medieval society, particularly in one part of the world, and then gradually spread around the world out of poverty. It was a poverty alleviation mechanism that it's not complete, it's got a long way to go yet. It's caused some new problems in that process around ecological sustainability. But it was a mechanism that enabled a group of humans that got bigger and bigger and bigger to solve some fundamental problems. Economies are knowledge-solving mechanisms. What we can start to do now, if we can sort of digitally connect all of the things in the world, bring them online, enable them to become visible to a mechanism, we can start to solve a lot harder problems. So challenges around dealing with externalities, that's sort of the climate change problem, a lot of ecological problems, a lot of just fundamental things that we're currently relying on governments to do, or trying to sort of re-engineer human belief systems and so on. We're using cultural mechanisms or political mechanisms to solve, which we're making some progress with that, but it's not. It's nothing compared to the power of sort of being able to harness economic mechanisms to solve that. So one of the sort of the reason that we see this sort of optimistic sort of argument about why this curve will continue to rise, not because of economies keep growing forever, but economies evolve to take on and start to solve much harder and deeper problems. So problems around internalizing externalities, classic sort of ecological type problems. Step changes in innovation, particularly around sort of a lot of biomedical type problems and opportunities. Just that ability to bring more and more resources to connect sort of capital around the world into sort of taking these things on. Where at the moment, the only mechanism we really have for doing that are either large corporations or governments or various sort of coalitions on that. Again, it's kind of an okay solution. It sort of works sometimes, but it's nowhere near as powerful as it could be. And it's this sort of argument that the more we can do this, the more we can sort of drive real-world assets on-chain, the more sort of we can start to bring just information from all from a full stack of information onto sort of trying to sort of solve these types of problems. So that's the argument for why a computable economy is good. Why this is something sort of aspirational that we want to work towards. Why the sort of next sort of continuation of that hockey stick isn't more and more industrial growth or post-capitalist growth. It's using global economic systems to solve even harder and more general sort of problems. So that's where we find ourselves. That's why we're sort of excited about this direction of what this type of institutional revolution toward computable economies can bring. Thank you.
All right, that's awesome. Let's go to the Q&A session, guys. So please scan the QR code here and ask the question. It's going to pop up on the screen. And you guys, here we go. Let's fast. Let's go for the first one. Who want to answer?
I'll take that one. Thank you. So the sort of economics that we're dealing with here is not traditional sort of neoclassical economics. The reason for that is that what we're sort of driving to is far more institutional economics, information economics, mechanism design, and trying to sort of understand what we can do with that as to design sort of global internet-based digital economic systems where what we're fundamentally engaged in right now is this new opportunity to essentially design economic institutions from scratch. These need to be integrated with economies as they currently exist. We'll use a lot of institutions that we've had from industrial economies to carry over for that. But there's an enormous opportunity here to just massively increase the scale and scope of things that are in the economy. And the first step to that is basically identification, attaching data to these things, enabling to be bought online. That process of bringing much more of the stuff in the world, the stuff that we care about and want to organize and try and sort of shepherd and so on, into the economy. So industrial economies did that in a big way from feudalism to sort of modern capitalism. That was a 600-year-old process of bringing a bunch of stuff into the economies, turning it into capital. But a bunch of stuff got left out of that. And critically, a lot of resources, a lot of sort of problems that a lot of sort of factors of production weren't sort of part of that. So I think there's a new opportunity here to sort of create a new type of economics. So we've called it computable economics for a computable economy, but that's the sort of challenge that we're trying to meet here.
All right. We have like 1 extra minute for you guys to answer the question, so don't be too rushed. We have time. All right, let's go to the second question. Which one you want to answer first?
Yeah, I can definitely put the presentation online. I'll put it on the Boson Protocol website, so bosonprotocol.io. We'll have that up later today. Yeah.
All right. Is the presentation publicly available for people? Yes. All right. Cool. Let me mark that up. Let's go to the third. Yeah. Can you elaborate that? More how?
There was one just up here as well. Was that?
Yeah. Which one you want to answer? You can pick any. Yeah.
What was the one previous? Yeah, this one. Can we answer that one?
Can you scroll down a little bit? Just that.
Oh, just the one above the presentation one. Yeah. Okay, so this, yeah, I mean, this is one of the core challenges of tokenizing a physical asset, and so it's this kind of physical asset oracle problem. So that, as I mentioned in the presentation, there are kind of three main ways of ensuring that you can have some control over a physical asset. One of them is to use a centralized sort of system and trust that centralized intermediary. But that kind of, well, it doesn't unlock computable economies, and is very much just using the current methods. So aside from that, you have two ways of doing it. One is you can lock up the funds, within a protocol, and the second is that you can use a trusted verifier and custodian to lock up the actual physical asset. And in that case, the protocol would still control who the custodian releases the asset to. And so those are the two main ways of enabling this for physical assets.
Yeah, let's do the last question here. Which one you want to answer?
The financialization of everything, that's an interesting point. So I don't see this at all as financialization of the world. What I see it as is the computization of the world. What we're trying to do is to bring all of the, anything that we want to be part of an economy, which means things that we want to organize and coordinate. Things that we value and want to organize and coordinate, we need to bring them into an economy. The standard way you do that is with property rights, or just attaching ownership and identity and prices and so on into something. One of the things that can go wrong with that is that it becomes financialized and becomes a speculative object. But the reason that you're wanting to do that in the first place is because you care about something, and you want that information in a system to coordinate. The flip side of financialization is basically politicization. When there are things and parts of an ecosystem and a global economy and so on that aren't part of the economy, externalities, what happens is that we have to use a different mechanism for coordinating them. That mechanism is usually politics. Sometimes that works great. If we have high quality politicians and everyone votes rationally, and we have a legitimate institutional process to produce only good political outcomes, that system really can work. It's just it doesn't always work like that, and not all countries have that sort of state. So this idea of sort of trying to bring in things that currently sort of aren't part of the economy, to turn them into part of the economy through a process of attaching, of sort of capitalizing them, or attaching asset or attaching identity to them, enables them to be computed by the economy. It enables them to be efficiently, rationally allocated, to find sort of the best uses for them. So, now financialization is a risk of that, but politicization is the sort of counter